Okay, welcome to week 6, day 1. So this is week 6, day 1 notes. And we are going to be practicing with our simplifying and multiplying rational expressions. To save time, I have gone ahead and screen captured the problems that I'm going to be doing. So at any point, if you need to, just pause the video and you can copy down the problem that I'm going to be doing for you guys. So the first thing that we are going to practice is just simplifying fractions. So rational means fractional, because if you think about the first 5 letters of the word rational, it's ratio. And most of the time, you guys write your ratios as fractions. And so we are going to be giving you rational expressions and later on rational equations to work with. So the first problem that I'm going to work, all I'm going to do is just factor and reduce. And this is actually something you guys have been doing numerically for a very long time. If I told you guys to just reduce 6 over 8, the reason that we know that it's going to become 3/4 is because 6 is 2 times 3 and 8 is 2 times 4. So mentally what you're doing is you're canceling the 2's out of there, and that's why it reduces down to 3/4. And so the only thing that's going to be, I guess, the next level up here is that the factoring is a little bit more work for these problems because now you're dealing with expressions with variables in them. So the first problem has x squared plus 5x plus 6 in the numerator, and so I would factor that, and that factors as x plus 2 and x plus 3. And then the denominator has x squared minus 4x minus 12, and that factors as x minus 6 and x plus 2. And so what that means is that now I have a common factor on top and on bottom. Both of those quadratics have x plus 2 as a factor of them, and so it will reduce out of there, just like the 2's did in the numerical example. And what that leaves is it leaves x plus 3 over x minus 6. And that is as simplified as that will get. Please don't think that the x's are going to cancel. Fractions will only reduce if the factors are being multiplied together. Okay, they're not individual separate terms. So this is as simplified as this one will get. So on number 2, we're dealing with just slightly more complicated factoring, but the process will be the same. So the first thing we would do would be to factor the numerator. This numerator simply factors by pulling out your greatest common factor. And the greatest common factor for this numerator is 5x. And what that leaves behind for this first term right here is it leaves behind a 2x. And what it leaves behind right there is a plus 1. And then the denominator, the first thing that you would want to do to factor it is you notice that all 3 terms in that denominator have an x in them. So you're going to pull out your GCF, which is x. It will leave you with 2x squared minus 7x minus 4. You can go ahead if you want to, and you can go ahead and cancel this x and this x. They will cancel each other out. They are factors of the numerator and the denominator. But for right now, that's all you can cancel out because you haven't finished factoring the denominator. So you will need to factor this quadratic right here. And you can use grouping. You can use your swing method if you use it carefully and if you remember all of the steps for it. So I would suggest that just to make sure that you recall your factoring methods, that you might want to pause the video now, go ahead and try working, factoring that quadratic for yourself. If not, then you can just keep on rolling, and I'm going to go ahead and tell you that this quadratic factors as 2x plus 1 and x minus 4. And so what you see is that now we have additional factors that will cancel out. We now have a 2x plus 1 on top and on bottom that will reduce out of there. And ultimately, all we're left with in our numerator is the 5, and our denominator is just the x minus 4. Okay, so that's how you factor and reduce these fractions. Okay, the next skill, it's actually using the very similar process, is to multiply multiple fractions together. And remember that when you multiply fractions, what it's reminding you of right here is that you multiply straight across. So if I said to take the fraction 2/3 and multiply it to the fraction, let's say 9/8, okay? I'm ultimately going to be just going straight across. I would do 2 times 9, which is 18, and I would do 3 times 8, which is 24, and then I would need to reduce it. And what you would see when you reduce it is that 18 and 24 have common factors with each other. Okay, and so what you can do is you can go ahead and factor it as 6 and 3 and 6 and 4 and cancel the 6's out. But what you could have done instead, let me erase this so that I can show you the alternate way. What you could have done instead is, instead of multiplying the numbers first and then reducing, you can factor and reduce as you multiply. And that's what this paragraph is trying to say. So the 2 and the 3 are already reduced, right? But 9 is the same thing as 3 times 3, and 8 is the same thing as 2 times 4, right? So what I can do is I can cancel this 3 and one of these 3's out as I'm multiplying, because I know that the 2, the 3, and the 3 are all going to become part of the same numerator, right? And then I can cancel this 2 and this 2 for the same reason, because I know that the 3, the 2, and the 4 are all going to multiply together there. And so I can cancel those 2's and cancel those 3's as I go. And so I just end up with 3/4 as my answer, instead of generating the larger answer and then having to reduce. And so hopefully after seeing it done 1 or 2 more times, we can drive that point home. So on question number 3, I've been given 2 fractions that I want to multiply together. So I'm going to go ahead and factor. Okay, so I factor this first quadratic up here, x squared minus 9x plus 14, and that factors as x minus 2, x minus 7. I factor the denominator down here, x squared minus 5x minus 14, factors as x minus 7, x plus 2, and it's being multiplied to this other fraction. Okay, and so this other fraction has 3x plus 6 in the numerator, which factors just by pulling out a 3 and leaving an x plus 2 behind. And then this denominator right here factors by pulling out an x, and it leaves behind an x minus 2. And since I know that when I multiply these fractions together, I'm going to go straight across through the numerator and straight across through the denominator, it really essentially is just going to become one big fraction. So anything that I see on top that is also on bottom will simply reduce out of there. So x minus 7 and x minus 7 will reduce. X minus 2 and x minus 2 will also reduce. And last but not least, x plus 2 and x plus 2 will reduce. So the only thing that didn't cancel was the 3 on top and the x on bottom. And that saves me having to do some really messy multiplication and then try to factor and reduce. Okay, so let's try one more. Let's try number 4. Okay, so if I look at number 4, the numerator of my first fraction, I could pull out a 3x, and I can do that. If I do that, though, it leaves me with a 1 minus x, and most of the time, the way that we write our factors is we write our factors as things like x plus 1, x minus 1. We want the x in front. So what I'm going to do is, instead of just pulling out a 3x, what I'm going to do is I'm going to pull out a negative 3x. And so that's going to change the signs on everything. If I pull out the negative 3 and one of these x's, it's going to make the x become positive that's left behind there. And it's going to make this 3x right here become a minus 1. So that numerator is now factored. Now I factor this denominator right here, x squared plus 4x minus 5. And that factors as x plus 5x minus 1. So I already see that one of my factors is going to cancel. But remember that I'm multiplying it to this other fraction. And so I'm going to have a whole lot more stuff in the numerator and in the denominator that will also cancel. Okay, so now I'm going to factor this numerator right here, x squared plus x minus 20. That factors as x plus 5, x minus 4. And then this denominator doesn't require factoring. It's just a 3x. There's nothing to worry about factoring it. And so, once again, since I know that everything on top is going to become part of my numerator, everything on bottom is going to be part of my denominator, I'm going to just reduce. Now, anything that I see on top and bottom. So, for example, the 3x and the 3x will both cancel. The x minus 1 and the x minus 1 will cancel. And last but not least, the x plus 5 and the x plus 5. And all I am left with is this negative that didn't have anything to cancel with, and this x minus 4 that didn't have anything to cancel with. And I can leave it written like this, or an even simpler version would be to distribute that negative through there and make it negative x plus 4. And so that is the simplified and combined answer. Okay. And then the last skill is division. And so in order to remember how to do this, all you need to remember is it says to take the first rational expression and multiply it by the reciprocal of the second. So remember that if I told you to take 3 and divide it by 1/2, remember that dividing by a fraction is the same thing as multiplying by its reciprocal. Some kids have been taught the keep, change, flip. Okay, so you're going to keep the first expression, change the sign here, and flip the second expression. But 3 divided by 1/2 is the same thing as 3 times 2 over 1. And so the answer you would get would be 6. And so really all that does is it generates one additional step over questions 3 and 4. Because once we have rewritten it as multiplication, it becomes just like examples 3 and 4. Okay, so that's what our first step is going to be. And then the rest of it will work out just like the earlier examples. So on question number 5, the first thing that we would do, and you can factor as you do this, I'm just trying to make sure that I don't lose anybody. So the first thing that I would do is I'm going to change this to multiplication. You notice I left the first fraction, I kept it the same. I'm changing the signs to multiplication, and now I'm going to do the reciprocal of this fraction. I'm going to flip it over. And so it will now have the 4x minus 6 on top and the x plus 2 on bottom. Okay, so now it becomes just like number 3 and 4. So now I'm going to go ahead and factor. And like I said, you can factor as you are rewriting it as multiplication. That's perfectly fine. Okay, I just want to do one step at a time to keep everybody on board. So the first thing I would factor would be the first numerator. So I'm going to pull a 7 out of that. and leave behind the x plus 2. The first denominator, I'm going to pull a 2 out, and it's going to leave x plus 1. And then I'm multiplying it by the second fraction, and the numerator of the second fraction factors by pulling a 2 out of that, and it leaves behind a 2x minus 3. And then the denominator of the second fraction does not require any factoring at all. There's nothing to do with that. And now we're ready to reduce as we multiply. So I'm going to go ahead and the 2's are going to cancel. And the x plus 2's are going to cancel. And that's all that these two have in common. So up on top, we still have this 7, and we still have the 2x minus 3. And in the denominator, we have the x plus 1. And so there's our multiplied and simplified answer. If you want to, you can distribute the 7 through, but you do not have to. Okay, just keep in mind that, like if you're taking the weekly quizzes kind of thing, that your answer choice might have that 7 distributed through, so it would just make it look like 14x minus 21 over x plus 1. Okay, both of them are acceptable. And so number 6 is asking you to do the same thing. It just has the division written as a different way. Instead of actually putting the division symbol between the two fractions, we've just written it as one very, very large rational expression, but it's saying the same thing. It's saying take this fraction and divide it by this fraction. So our first step would be to rewrite it as multiplication. So we will be taking the 7x over 2x minus 10, and we're going to be changing it to multiplication, and then we're going to be reciprocating or flipping the second fraction. And so it would be x squared minus 11x plus 30 on top, and it would be x squared minus 6x in the denominator. And now we can go ahead and factor and reduce as we multiply. So my first numerator just stays a 7x. My first denominator, I'm going to pull out a 2, and that leaves me with x minus 5. The second numerator factors as x minus 5, x minus 6. That's what gave me the negative 11 in the middle and the positive 30 at the end. And then the second denominator factors just by pulling out an x, the greatest common factor, and it leaves me with x minus 6. And so now we are free to reduce as we multiply. So I'm going to cancel this x and this x. I'm going to cancel this x minus 5 and this x minus 5. And I'm going to cancel this x minus 6 and this x minus 6. So the only thing we are left with is a 7 on top and a 2 on bottom. And so our answer is actually numerical. We've eliminated all of the variables, and it's just 7/2 as our answer. Okay. So these are your practice problems for this particular set of notes. Remember, these are optional. These are not what's going to be for a grade. But the answers will be posted on Edmodo, and we will have the Zoom tutoring to help if you guys have any questions on these or the extra practice. Take care.